Howdy, welcome to our webinar today, Preparing Your Network Infrastructure for the Internet of Things. My name is Billy Moran, I'm the Marketing Director here at Uplogix, and I'm joined by James Dollar, our CTO. Before we get going, we're going to do the housekeeping things. Everybody is on mute, so if you have any questions, use the Q&A panel or the chat window and send it to me, and we'll make sure they get answered. And also, we are recording today, so if there's something you miss, or if you have to drop off, or if you want to share it with a coworker, we'll send out the link to that later today. The big question, the Internet of Things, is this just marketing hype or is it something you really need to worry about? We did a highly unscientific test. We did a Google search for Internet of Things and looked for some images showing us applications. And you might notice these are all very graphical, hypothetical kind of pictures. So it doesn't necessarily lead you to think that this is something that's happening today. However, if you look on the news side, there is a lot of investment going on in Internet of Things activity. So there's big name companies starting to join together to put the parts together that are going to make this a reality, including a consortium looking to standardize some of the components of that, which is usually a good sign of industry interest at an early stage. We just got back from Cisco Live last week out in San Francisco, and Cisco's clearly betting big on Internet of Things. They call it the Internet of Everything. And the CEO, John Chambers, went a little deeper into that during his keynote and kind of defined what they see as the Internet of Everything. And it's more than just the connectivity part, it's actually changing things. Some of the examples he gave of this were fog computing, where you're doing more processing out at the edge of the network inside a router. So it's not necessarily sending all the data collected to the cloud, because that's not really necessary if you can process some of it locally. And another application that they did talk about was they brought out one of their customers, Shell Oil. And Shell was talking about one of the things that they've been doing in their drilling operations, where they have these platforms out at sea. They could be pretty much anywhere on the planet, and they're all connected with high-speed satellite connections back to their central offices, where they can keep their geologists and geophysicists and drilling experts off the rigs and in one place where they can actually monitor multiple rigs at a time. And they can actually do the drilling operations from a command center that are relayed back to the rig down into these intelligent drill bits. And one of the things that stood out for us here at Uplogix about this application is we actually do a lot of work with satellite providers in the oil and gas industry. We have for a number of years. And just the importance of these connections on these isolated rigs is becoming ever more important every day.
Right, and if you can't depend on that network connection to be up, you can't take advantage of the expertise that's centrally located, and you have to keep sending them out and to live on the rigs where it's difficult to keep people motivated to do that all the time.
Exactly. So it's not just they need their TV out there. This is money. Operations come to a halt if they can't maintain these connections. Another presentation out at Cisco Live was by Mola Anand. She's Vice President out at Cisco. She was talking about that, the Internet of Things is actually a collection of different types of network infrastructure. So there's the familiar machine to people, right, where you have access to a application or a server somewhere. You're pulling in data to do your job. There's the machine-to-machine interface where people aren't even involved. And then the people-to-people, which is more of the social networks that are definitely a part of today's connections. Here at Uplogix, we deal primarily with the machine-to-people, and as a result of our automation and where we sit in a network infrastructure, we do more of this machine-to-machine interaction. So James is going to talk to you a little bit more about this and show you specifically some of the functionality we have that's applicable directly to Internet of Things applications. And with that, I'm going to hand it over.
Yeah, so obviously the scale of this is one of the big changes that are happening. Not only are we connecting toasters and refrigerators and building air conditioning units and things like that to the network that were never connected before, but they're all intercommunicating on their own, and that's where we really feel like Uplogix has been already pioneering that world. Uplogix Local Managers are designed to plug into network devices and in a very machine-to-machine way, work like a person, but in the response time ability of another machine to monitor different applications and systems and then take corrective action. We'll go through a couple of examples of that. But finally, not only does it need to scale, but it's got to be secure. The more of these devices that are put out there, they open new exploit points into the network, as we'll see a little bit later in the slide, but they're also devices that were really never designed very well to be sitting on the internet and broadly routable and really exploitable. And so it's important to front-end them and protect them in some ways. A couple of places that Uplogix has been able to do that. First is as we are able to collect data about those tasks. Those drilling rig examples are the most extreme, but even at the even more common building automation systems and things that are more terrestrial based, the first thing that you need is to have that system up and dependable, or you're back to having to send people on site to both run those type of drilling rig applications as well as resolve problems. So first thing is that ability to poll very often to find a problem very quickly and then resolve it. And that's one of the places that Uplogix really provides a lot of value, is that ability to poll without regard to the network state and without using the network. So it's almost a continuous collection of state data and the continuous processing to determine if it should run one of our runbook responses automatically. And then the other place that it really fits into there is that even when it's functionality that needs a human involved in the troubleshooting process, all the tools that you need locally, different network tools and configuration files and ways to do your job so that you don't have to go on site, that ability to do crash cart level access and those kind of things is really critical to be able to fulfill that real vision. And then obviously security is a big important part of this, as we mentioned, but there are compliance requirements, and as the Internet of Things becomes so many more devices out there, the scale of it just becomes daunting. And then that ability to break that up in a distributed way, that's one of the ways Uplogix as well breaks the administration tasks down into manageable buckets that we center around the Uplogix Local Management platform. We'll get to that in a couple of seconds. So where does Uplogix fit in the network? There are already strong tools in the Network Operations Center that do network management today, some of those brands that you recognize. Uplogix has a component that fits into that part of the network called the Uplogix Control Center, and it's our gateway to all those different products. It's the portal to get to all things Uplogix, and it really is the kind of the single point that manages all the Uplogix environment. But it's the component that sits in the network. And then over some wide area network, or maybe just across the hall, we connect through different networking components, routers, WAN accelerators, switches, other devices. And as those tools on the left poll over the network regularly, we don't really replace that functionality because they've already got lots of functionality available for that. But the local manager component racks in the same racks with those gears, with that gear, connects over dedicated connections to each one of those devices, ideally console port connections, and then probably the next best would be dedicated Ethernet connections to each device so that we have a reliable way to collect data about those devices and a reliable way to execute recovery tasks that doesn't use the network. Almost always include power control in this because it's an important tool to be able to take power cycle actions, but it's also valuable to monitor just like we monitor interface statistics and backplane information about routers and switches, we monitor power that's coming in and making sure there's enough voltage and be able to cycle power to devices that are non-responsive. Again, that happens out of band in the same way. And then the local manager almost always includes some out-of-band component that will connect back to the control center when there's a problem with the network. Anything from a V92 modem to 3G cellular to low Earth orbit satellite. Some way to get there worldwide so that your entire environment has the same footprint of out-of-band functionality. So we talk about that kind of being more branch offices or data centers or things, but it's just as applicable in an environment like an ATM machine that has multiple devices. Again, generally non-network based monitoring of the cash machine, the scanner, and the UPS and the router and the other things that provide that value is still to make the ATM system work and run on efficient protocols. It needs that same ability to collect data about its system, and then when the cash till is the problem or the UPS is having an issue, to get the right team focused on working on that. You don't want to get the router guy out of bed in the middle of the night to work on the cash till, and so that's still key to be able to do that local management function. Just as often, it's though broadly distributed military installations that are way out on the edge. It's often those drilling platforms, as John Chambers' example, again, to take advantage of being able to centralize those management actions by the knowledge workers. It's really important that these connections stay up, and a satellite environment is one where uptime's nowhere near as reliable as terrestrial-based networking. So it's really critical that when something goes wrong, someone or something like an Uplogix Local Manager needs to be in there to resolve that problem quickly. SCADA type devices up and down a pipeline or remote monitoring station for any number of industrial applications to, again, provide that value of having the more centralized expertise, able to look at multiple systems at the same time means we need to have a reliable way of collecting data, a reliable way of executing changes in that environment. Or even, as distributed as we see the ubiquitous cell towers, generally one about every 4 miles in every industrialized area, or even way out in the middle of nowhere nowadays. It's really important to have that system up. It needs the ability to be managed completely without using the network, so it can be brought back online. We'll go through some examples of that in just a second. So not only are we living in the branch office data center type world, but in many industrial-like applications. So one of the things we talked about early was intensive monitoring. So to find a problem quickly, you have to poll very often, and that's not very practical across a wide area network or even a local network because it interrupts the device's ability to switch packets and it floods the network with traffic. So Uplogix does all that monitoring all over console port connections, ideally. So our polling sample is by default every 30 seconds, so we're going to find a problem very quickly, have multiple samples of that being a problem in the first minute or two of the outage, and then use that data collection interval to execute first-level actions. It's generally the simple things that if you just did them in the first minute or two of the outage, it would resolve the problem. But as we're polling in this frequency and we have a problem, like a router has a network interface that goes down or has some kind of other issue, that polling interval not only lets the local manager find the problem very quickly and then start executing these first level actions that are, in this case, vendor recommended best practices that 20 to 40% of the time solve problems if they could just be executed in the first couple seconds of the outage. And so the actions such as clearing service modules and cycling interfaces on and off and pulling showtech information are all valuable first level actions that so often restore the problem. But even the ones that are down like reboot and power cycle, that ability to make decisions the same way a first level tech would might take us right to those power cycle type actions if they could get the connection back up in under 5 minutes. And in this case, without any NOC administrator or any other triage occurring. So while that's something that generally you don't want to have to do, if you could resolve the problem very quickly and even very often inside the sampling window of most of those tools at the NOC to even find that problem, then it's a valuable step to take and a reasonable one. That dramatic service improvement, again, happens because of the polling interval. In most network outages, there's some unknown period of time between, something's wrong, but we haven't polled for it. With most tools, that's between really 0 and about 15 minutes between you when you have escalated a problem and said, yes, it is actually something that is broken. Usually a couple of samples have to miss before that's true. And then that identification process where you try to figure out, is it the router, is it the circuit, is it some routing protocol that's gone down. And then that isolation process of trying different actions to see if you can resolve the problem, generally starts at about an hour and takes hours to resolve. And then through that resolution processes, generally hours to maybe days if you have to send somebody on site. But again, we'll focus around that SLA timer starting at about 15 minutes from the time the first packet drops to the time we start calling it a problem. So with Uplogix, again, our polling frequency is very often. So we're going to have that unknown period of time, generally less than a minute. And then because we're directly connected to each device, we can identify which ones are meeting or not meeting their SLA criteria very quickly. So we generally know in the first 30 seconds, which component is failing, and generally we could respond in that period of time, but we want to have a couple of different samples of that. So generally we call that isolation process of having multiple samples of that, having a consistent problem over time. And then we start to execute those resolution steps that we went through in the previous example, the no shutting of ports and the cycling of or clearing service modules and pulling the show tech actions. Those are the kind of things that we're doing, and we're doing it as often as pulling new data, determining that it's still a problem and we haven't solved it yet, so we take the next triage action. Again, focused on reducing that time to respond, detect and respond to generally inside of the sampling window of most systems network systems management tools. So if we can find that problem, resolve it, even if we take broad, bold steps like power cycle, it gets the network back up and running, and often don't even take an SLA yet, even take into account a power outage. One of the ways we do that is by validating service levels from the remote perspective. So lots of tools are at the NOC trying to do service level management that take in net flow data or do synthetic transactions from the NOC's perspective, but they're really from the kind of the outside going in. We want to look at it from the remote side, going to where the remote connect. So you might envision this type of network where you have a NOC that is kind of core to your monitoring, but you have two sites that communicate between each other. So we'll talk about this as being kind of a virtual connection between those two, and where we would do synthetic network tests. Anything from TCP performance, an HTTP transaction that includes DNS lookups and time to first and last byte, result code. All those things that we use to determine end-to-end functionality really don't have anything to do with the NOC, and so that's not a great place to sample from. We want to know what it's like from point A to point B across the network, and so we do those samples, really from point to a point, or maybe even a voice test where we do a real voice call with pre-encoded humans speaking phonetically balanced sentences across the link that most accurately reproduces what a voice call would sound like. Those are the kind of things that we use to validate that not only do we have an outage condition in our communication with the router, but the business use of the network is also failing, and lets us be bold enough to take those types of actions like power cycle in the first couple minutes, because not only do we see those first level actions not be successful, but we see the network tests also fail. And so that, again, reproduces that first level text thinking process. One of the other places that we provide lot of value in this area is the ability to make changes with a safety net. And so generally a technician logging into a router outside of an SLA window, before he logs into that router, he logs in through the local manager and it pulls the state before he's logged in. And so we have a baseline before he started. And then as he's sending commands to the device and making changes, he might just spoil a route back to his NOC and other network components are still up and running. Or he might apply an access control list that just knocks his interactive connection down. Nothing else fails in the network, and so it's dangerous to take the reload in type commands in this area. But it allows, in the very same way, our system is designed to detect that inactivity, and then after 5 minutes by default, we'll pull and store the running configuration again, diff it between the one that we saw previously when he logged in, and then if they're still logged in, we ask the user to confirm that change by displaying this is what you did, and if they don't, by default, we compute a back out to that device and roll that change right back, taking us back to the last known good state automatically without tearing down the network and all other components by reloading, really just backing the single change out. We do that same type of functionality with not only configurations, but broad-based, centralized changes like different blocking new security exploits or things like that, or doing operating system upgrades to devices. We can roll out those kind of changes, and if the device doesn't pass a checkpoint along the way, we'll roll it right back to its last known good operating system and get it right back up and running. Again, those kind of safety net things lets you make changes like this, even inside your maintenance window, but often when you can't wait for a maintenance window to make changes. One of the other ways we do that is providing an out-of-band topology using the V92 modems or GSM or 3G. And the way the system works by default is that it does a phone home connection from the local manager back to the NOC so that it doesn't create war dialable endpoints, and it creates an IP path back when there's a problem. So by default, it samples up to 3 endpoints every 30 seconds and tries to validate that it can get across the network to those 3 endpoints. And when all 3 fail, by default after 2 minutes, imagine the router might go down or some other component that triggered that, then that's when the local manager does that phone home connection. So again, it brings up an IP path. It reconnects network management protocols like TACAX and Radius, like syslog, like NetFlow forwarding, all over that out-of-band channel. It allows the network team in the NOC, if those first-level actions that we were executing didn't resolve the problem, then it lets that first-level team at the NOC get all that telemetry information about what we've already tried and the state of those devices, and take over that troubleshooting process with all those artifacts by coming across that connection with an IP path that's secure, maybe still using their one-use passwords from TACAX or Secure ID or something like that, and then even having multiple users over that same connection. Finally, it's able to bring back up point-to-point experience testing and things like that that let the escalation engineer know that the changes that they're making were good and that the network is back up and running, meeting its SLA after they've executed those changes. So local management doesn't work in a vacuum. We don't want it all happening out at the remote and not sharing this information with the tools that are already at the NOC. So one of the places that is very valuable are tools like CA Spectrum, and when they can't connect over the wide area network to that router, they really just pop up with a screen that says, I'm not sure what's wrong, I can't get to any of this devices at this site. And that's where Uplogix backfills those systems with data. So in our previous example, we bring up that out-of-band connection, and then as we bring up the out-of-band connection, we start forwarding on to these tools the remote's perspective of the problem. So not only, maybe we missed that router poll at the top of the list where it says devices stop responding, but then we start seeing the backfill of information like the interface loss of signal and protocol state being down as being the remote's perspective of that problem. And then we start seeing, as we see the individual actions occur through automation, the clearing of service modules and the cycling of interfaces, exactly in that same scenario, that gets backfilled into Spectrum so that we see from the central tools perspective, what's going on remotely. And then at the end there, we're back to polling, devices are back up in green, and the network is back to business as usual, where we tear down the connection and go back to monitoring. So it's really a lot more than taking these automated actions at the remote site and you're not hearing about them, but it's designed to make all those tools at the NOC stronger by backfilling them with information that they can't get otherwise. Finally, none of this would work well without locked-down access. Uplogix provides many functions in this area. The first one really being that role-based management access, even when all the network's down, even when TACAX and Radius are down and you have to send someone on site. We have cached credentials and cached permissions that are still per user, so you're never down to break glass and shared credentials. So you're not able to overcome those security challenges even when the network is down. But when the network out of band is working, some of those components does reconnect, as I mentioned, the TACAX and Radius reconnect out of band. We provide, again, that SLA validation of business applications, lets the technicians know that the voice calls are back to working as expected, and the web transactions are succeeding, and the SYNAC round trips are responding on time. All of the system Uplogix provides, encrypts network-based traffic, SSH-v2 by default for really almost all of our interactions to the local manager itself, two-way SSL for all of our communications back and forth from the local manager to the control center component, and obviously web services and things like that for browser-based connectivity. And then, as I mentioned, out-of-band defaults to a phone home so that it doesn't become a war dialable, what the security guys call an attack vector. It's not another place that they can be attacked in the network. And we see some of that in examples that are happening in the news today, where, as in the Internet of Things conversation, we keep plugging more things into the Internet. Any one of those components that are routing packets around your network could be used as a gateway to cause great havoc inside your organization, as we've seen recently with Target. A very good example of what Uplogix often provides is really locked down access to those vendor accessible tools, so that they're not able to navigate around the network, and they're not able to get in and see PCI card database data or network management traffic when they're in trying to work on the building air conditioning system. And in the same ways, the network team can't get into those systems that are air conditioners, and the database team can't get into the network tools. It's a very granular system that, again, caches all that information, and it's really always available to gate not only access, but reporting and alerting and some of those kind of things.
All right. So as we kind of start summing up here, one of the natural tendencies is when there's a lot of unknowns kind of coming is to hunker down, and then you see scary quotes like this one from John Chambers from his keynote, where he's predicting a lot of brutal consolidation in the industry. So one of the things that you want to know about, because it's not possible just to sit and wait. Everything is changing, and a lot of these connected devices aren't necessarily going to be driven by IT. It's going to be the IT group's customers that want to connect a lot of these things. And so one of the key things is you need flexible solutions. And one of the things about Uplogix is while we play really well with a lot of the big guys and we have advanced drivers, pretty much since we interact at such a basic level, we can do a lot of our management for just about any device with a console port. So it's kind of it's a benefit for being able to adapt to things you don't even know are coming yet. And as you see, so these are a couple slides still from John. They're predicting big things, both public sector, private sector. A lot of money going into this, and really there's nowhere to hide. Pretty much every industry they're predicting is going to be impacted, and both good and bad from some of these changes coming. So as we finish out here, with all of the things coming that are going to be connecting to your networks, you got to learn how to work smarter, because for most people that we talk to, the way things are now, there's not a lot of scalability still left in your network management. So you got to find the things that you can automate, and they need to be things that you can automate with confidence. So that is our presentation. We've received a few questions as we've been going. And so I'm just going to throw these at you, James.
All right.
So on the ATM application, I think they're asking, where is it that Uplogix goes?
Yeah, so that racks in the ATM right next to the different components. Hard cable connects to each one of those devices as possible. Executes the simple, are you okay type actions, or runs the very complicated runbook of Cisco-based commands to the Cisco-type devices in that network, and validate the state. And then when there's a different component that is degrading or failing, then it certainly alerts the team that's responsible for it, like the UPS alarm might go to the facilities team, and when the cache till is out of 20s, that might go to a different group, and when there's a network problem with the router, to a different group. Those are increasingly becoming different components of the network, but they have multiple business units responsible for the different components, all part of delivering cache out at the edge. And so it's, again, important to be cable connected to each one of those devices, so you're not sending all that traffic over the generally cellular networks today. And then that ability to automatically, not only create that alarm, but also host as the technician comes in to resolve the problem, how they get to that device, and validate that it's a problem, or now that they're sending the armored car with new 20s, that they get the right component in.
And I know one aspect of this, we have a bank out on the West Coast that's doing this, and there's a lot of acquisitions in the financial industry, and when that happens, you integrate, or you have to integrate, or you hope to integrate a lot of very different systems. So having kind of a standard
this becomes the abstraction layer to whatever the acquisition. It's the DMARC for management. And if you have a Cisco shop and it's a Juniper only shop, and you have lots of people that don't have a lot of experience with that, it really helps as the two teams come together to help to merge into one company.
Okay, this is one we get all the time. So do you offer local management as a service?
Working on that. We do have a partner that has that in the plan right now, and that should be something that we're able to do in the near future. So stay tuned.
All right, and another softball question here. It's how many devices can Uplogix manage, which is one we also get, and we've built in an extra slide, I think. There you go.
Yeah, this is the number of deployment options. On the top, we go up to actually 38 devices, and the Uplogix 5000. And then good for data centers and different components. That's a scalable, so I can start with 6 ports and then grow basically 4 ports at a time up to that size. We also have the Uplogix 500, which is a fixed 6-port type product. Both of those have no moving parts inside, and work to about 65C in our testing. And then we'll also deploy as a virtual machine on Cisco SRE blades, and then run completely on Cisco gear, so that's popular in the Cisco-only world. We'll also run as a VM in a variety of other environments that are customizable, so that we have lots of different ways to do that. Virtualization lets that run on practically any hypervisor type product, so that you don't have to send out hardware.
All right. And the 16-port cards that get the 5,000 up to 38, I don't believe are quite on the price list yet. So you heard it here first.
Yes.
And I think, you have anything else?
Nope, that's all the questions. Thank you guys for taking time today.
We're right at our 40 minutes that we advertised, so thank everybody for coming today. And like I said, we'll send out a link with, we'll send out an email with a link to the recording, and we hope to talk to you again soon. Thanks.